Astronomers from the Breakthrough Listen project, including Harvard astronomer Avi Loeb, identified a tantalizing radio signal coming from the nearest star to the Sun, Proxima Centauri, and think that NASA's James Webb Telescope should be able to identify any man-made lights on Proxima b. They detected the signal using the Parkes telescope in Australia. Proxima Centauri is an M-class red dwarf star with a mass of only 12% that of our Sun. This infrared star harbors an Earth-sized planet that orbits in the habitable zone, where liquid water could allow the chemistry of life on the planet's surface. Proxima b is 20 times closer to its host star than Earth is to the Sun, and observations indicate that the exoplanet is tidally locked, with a permanent day side and night side. The day side would most likely be inhospitable due to the constant flow of intense radiation from the parent star. But the night side could harbor life, leading scientists to believe that any potential technological civilization on Proxima b might choose to transfer heat and electricity from the warmly illuminating day side. According to Professor Loeb, a civilization may use powerful mirrors or require very bright LED-style lights to illuminate their buildings. Therefore, NASA's James Webb Space Telescope may be able to detect artificial light on Proxima b. According to the Breakthrough Listen project team, scientists can configure the new telescope to spot evidence of LED light on the planet Proxima b because the James Webb Telescope is bigger and more sensitive than Hubble. Because the James Webb Telescope is bigger and more sensitive than Hubble, it will allow us to peer farther into space and extend the search for artificial lights from the Kuiper Belt to exoplanets like Proxima b, Loeb says. The researchers used light curves from the planet and its host star to see if they might spot artificial lights on Proxima b's dark side. If the artificial night side illumination of Proxima b reaches 5% of the natural day side illumination, JWST could detect the artificial light with 85 certainties, and if artificial illumination were to reach. The detection confidence of James Webb rises to 95%, but only if the near-infrared spectrograph or near-a-stack-an instrument on JWST performs at its best. If not, the team suggests that future observatories like LUVOIR, short for Large UV Optical in Surveyor, might be able to detect this artificial illumination. Professor Loeb is also involved in the Breakthrough Starshot project, which aims to send high-speed laser-guided light sails to Proxima Centauri. The search for city lights on habitable planets may sound speculative, but Loeb believes it is worth pursuing a potential technosignature with planned instruments. The astronomer previously published a study suggesting that the interstellar asteroid was humanity's first contact with an extraterrestrial intelligence artifact in just 20 years, but he has now switched his attention to Proxima b. For many alien hunters, this planet is a top contender in the search for intelligent alien life beyond our solar system. A group of scientists just published a paper explaining how the James Webb Space Telescope, which was launched, can identify alien words with established agriculture. Isn't it intriguing? So far, we've only encountered life on Earth. But whether in the shape of microscopic organisms or advanced civilizations, humanity have always tried to locate it elsewhere. Our forefathers lived for nearly 6 million years, but modern Homo sapiens emerged in Africa about 200,000 years ago. However, true human civilization began around 10,000 years ago, when farming arrived on Earth for the first time and humans transitioned from hunter-gatherers to farmers. Cities began to evolve as humans learned to use natural resources to manufacture commodities that sustain life. As a result, Earth's appearance changed. The same thing may happen on other planets, but we've never had the technology to see it, at least not until today. Scientists are hopeful that we may soon identify exofarms on distant planets, and the successful deployment of the Webb telescope will boost the hunt. The Space Observatory is equipped with cutting-edge technology, such as a massive mirror and ultra-sensitive detectors that will allow us to study many undiscovered exoplanets orbiting their parent stars. If photosynthesis is operating on a particular exoplanet, then plant husbandry would produce detectable signatures, much as it does on Earth. Plant cultivation, according to the new report, requires a planet with active hydrological and carbon cycles, as well as the availability of nitrogen in the soil. Nitrogen makes up about 78% of the Earth's atmosphere. However, because atmospheric N2 is a relatively stable molecule, it's difficult to provide it to plants. As a result, the usage of nitrogen fertilizers in agriculture is critical for increasing productivity. It facilitates plants' access to nitrogen, resulting in the release of greenhouse gases including ammonia and nitrous oxide. According to the latest research, Webb's telescope might detect these molecules in an exoplanet's atmosphere, which could serve as a remotely detectable spectral signature of technology. On an Earth-sized planet, ammonia returns to the ground in a couple of days, indicating continued agricultural activity. However, unlike ammonia, nitrous oxide can persist in the atmosphere for over 100 years. This greenhouse gas is also produced by combustion, but the study's authors believe that, like us, other civilizations will realize that combustion is unsustainable and will phase it out. As a result, this could be a sign of agricultural activity. Methane, emitted by agriculture, rice cultivation, and ruminant ranching in particular, as well as biomass burning, landfills, and energy consumption, is another greenhouse gas. This could be another hallmark to keep an eye out for. Human activities produce about 70% of methane, and the amount is increasing. This is tremendously harmful to our climate, as methane has been responsible for over 30% of global warming since pre-industrial times. Overall, agricultural science could only appear on a planet that already supports photosynthesis. Webb's powerful infrared eyes can scan exoplanet atmospheres with adequate sensitivity to confirm the presence of water, oxygen, and carbon dioxide, as well as traces of ammonia and nitrous oxide, all of which are key signs of extraterrestrial cultivation.